Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this video is regarding series and we will be doing questions from past papers. So selected questions will be here, selected and critical to understand the topic more quickly so that you will be enabled to attempt questions in your CIE exams. So let's start. This first question is from Summer year 11, 2011, and it's paper 1 variant 1 and question number 8. The question says a television quiz shows a television quiz show takes place every day. On day 1, the prize money is $1,000. If this is not 1, the prize money is increased for day 2. So it's getting increased for day 2. The prize money is increased in a similar way every day until it is 1. The television company considered the following two different models for increasing the prize money. Model 1, increase the prize money by $1,000 each day. Increase the prize money by $1,000 each day. Model 2, increase the prize money by 10% each day. So again, we have two models, and in both the models, there is an increase. In model 1, it's an increase of $1,000 each day, and model 2 is for 10% each day. So for model 1, we can see that for each day it is in getting increased by $1,000. That means over here we will be following arithmetic progression. For model 2, there is a percentage increase of $10 each day. So here I should know that there is going to be a geometric progression applied here. So on each day that the prize money is not 1, the television company makes a donation to charity. The amount donated is 5% of the value of the prize money on that day. On that day meaning on that particular day, whatever the amount is, 5% of that amount goes for charity. After 40 days, now this is our N, after 40 days, the prize money has not been won, so calculate the total amount donated to charity. So donated to charity, that means first we have to get the total amount on the 40th day, which shall be there, so that the prize was not won for 40 days. So that total amount, on that total amount, we shall be having a 5% to donate for charity. So first part says if model 1 is used. So we have discussed that model 1 is regarding our arithmetic progression. So let's start taking in the data. So on day 1, we are doing the solution here. So on day 1, that means it's the first day, therefore we are talking about the first term, which is going to be our A in this case. The prize money is $1,000, meaning on day 1 we are talking about $1,000, which is our A, and then it's increased each day. And if we look at model 2, they are saying it's the increase in price by $1,000 each day. It's the increase in price by $1,000 each day. Here it says it's the increase the price money by $1,000 each day. So $1,000, $100,000 each day. That means our D needs to be a $1,000 here. Now this means that in arithmetic progression, if the first amount is 1,000, then the second needs to be a 2,000, and the third needs to be a 3,000, and so on up till we have the 40th term. So up till we have the 40th term, because they are saying it should be after 40 days. After 40 days, the prize money has still not been won. So N here needs to be a 40. So we shall be taking our terms up till the 40th term. And here also I have my value of N, which is a 40. So if model 1 is used, we have to get the prize money has still not been won, and we have to get the total amount donated to charity. So for the total amount, we always have to get the sum, and for that sum for 40 days, we know that Sn is given by The sum formula for arithmetic progression is n by 2 times 2a plus n minus 1 times d. So the sum of the money up till 40 days shall be n is a 40, that is divided by 2 times 2 times 1000 plus 40 minus 1, which is a 39, and d, which is a 1000 again. So the total amount that is there and has not been won up till 40 days is going to be 20 times 2000 plus 39,000 here. Or I can say that the total money which has not been won up till this time period shall be 39,000 plus 2,000, giving me a 41,000. Or I can say that this money up till 40 days is going to be 4 zeros and then 82,000. Now, this is the total money up till the 40th day, which has not still been won. So now the question was asking us for the amount donated is 5% of the value on that day, and we are supposed to find the total money donated to charity. So we know it's the total money has to be 5% of that amount on that day, meaning on the 40th day, and this needs to get donated to the charity. So I shall be getting the 5% amount here. Therefore, I should say for charity amount here, it's the charity amount which should be equal to 820,000 into 5%, or I can say that this amount then is going to be a 41,000. So $41,000 shall be donated for charity following model 1, which is for arithmetic progression. Now the same question says, after 40 days, the prize money has still not been won. Calculate the total amount donated to charity if model 2 is used. So for model 2, we know that increase the prize money by 10% each day. So increasing the prize money by 10% each day, that means if the prize money in percentage, if I just look at the prize money for the first day, then we know that on the first day the price there was 1,000. The price there was 1,000, and then I should be increasing it by AR and then AR square, so on up till the 40th term, which should be AR to power 39. So these are the terms which shall be there for geometric progression. So we are following model 2 here. So for model 2, we shall be needing our common ratio. And because the question has said that there is a 10% increase each day, so for 10% increase each day, I should say that in terms of percentage, if on the first day, my amount is 100, then on the second day it should be 110, and so on. I'm just talking about in terms of percentage. Therefore, I can say here that my common ratio is going to be 110 divided by 100, which shall be equal to a 1.1 here. So again, I should be getting the sum on the 40th day, the total amount on the 40th day, and this then shall be given as a r to the power n minus 1 divided by r minus 1. So I have the value of a, I have the value of r, and I have the value of n as well. A was 1,000, r is 1.1, and I have n, which is a 40 over here. So substituting all these values, I should say that the total amount on the 40th day shall be 1,000 times 1.1 to power 40 minus 1 divided by 1.1 and a minus 1 here. So sum the total amount up till the 40th day, or the sum of the amounts or the terms up till the 40th day, then is going to be 1000 times 1.1 to power 40 minus 1. Let's calculate that amount. 44.2593 divided by 0.1. So this amount then shall be 4,2592.55, and again it's the 5% that has to be donated for charity. So getting the 5%, I should say that this amount then is going to be, the charity amount then is going to be 44,2592.55 into 5%, meaning 5 over 100. So this value for charity is going to be 22,129.63, or I can say that it can be three significant figures. It shall be $22,100 that shall be given to charity here. So this is how this question needs to get solved. So this question is from summer 2010, May-June 2010, paper 1, variant 2. And here they are saying, part A, it says find the sum of all the multiples of 5 between 100 and 300 inclusive. That means 100 and a 300 that has to be there. So 100 and 300 inclusive. So first thing is to find the number of terms here. Being a multiples of 5, I know that the difference has to be a 5, sorry. The difference has to be a 5, meaning inclusive. So starting from 100, I should say that my first is 100. My second is going to be 105. My third is going to be 110. These are the terms up till 300. So these are the terms that I have. So I have the first term, which is 100. I have the last term, which is a 300. So I just need to find out the total number of terms that lies between this sequence here. So it's the Tn formula, which is equals to a plus n minus 1 times d, or I can say that it's the last term, which is a plus n minus 1 times d, if we are talking about the last term here. So L, the last term, is a 300, which shall be equal to the first term, which is 100, plus n minus 1. We don't know this value of n, but we know that for multiples of 5, the common difference has to be a 5 here. So 300 minus 100, that gives me a 200, which equals n minus 1 times 5, or I can say this is a 200 divided by 5, which equals n minus 1, or it's a 40 plus 1, which equals our n value. So our n comes out to be n plus 1. So we can say n plus 1. That means the total number of terms that I shall be having here is going to be a 41. So we have the n value here. We want the sum. So to find the sum, that's not at all difficult. I should just be applying the sum formula. And the sum formula for nth terms, we know it's going to be Sn, which is equals to n by 2 up times 2a plus n minus 1 times d. So up till 41 terms, the sum shall be 41 divided by 2 times 2 times 100 plus 41 minus 1, that gives me a 40 times d, which is going to be a 5 here. So sum of all the 41 terms shall be 41 divided by 2 times a 200 plus a 200, which gives me a 400. So it's 41 divided by 2 times a 400. 2 and 400, they get simplified, and I can say that my sum is going to be, sum of all the 41 terms is going to be a 8200 here. So this shall be the sum of all these terms here, which are multiples of 5. Part B is talking about geometric progression, which has a common ratio. So for part B, solving for part B here, it's a geometric progression. It has a common ratio of negative 2 by 3, and the sum of the first three terms is a 35. So part 1 says find the first term of the progression. So to find the first term of the progression, it's the formula Sn, which is equals to A times 1 minus r to the power n divided by 1 minus r. So you can see, because my r value is less than a 1, I have just switched the formula to 1 minus r to power n divided by 1 minus r. They have given us the sum of the first three terms, so I shall be going for S3, which should be equal to a 35, and this then is equals to A times 1 minus negative 2 by 3 to the power of 3 divided by 1 minus 2 by 3 here. So it's going to be 35 times 1 plus 2 by 3, which can be equal to A and 1 minus and a minus 8 divided by 27. So this then is going to be 35 into 5 over 3, which is equals to A, and 35 here gets simplified, and I shall be left with 5 by 3 into 27, which is equals to A, or I can say that my A value here is a 45. Part 2, it's asking for sum to infinity. So we know that for sum to infinity, I should be having the first term, which is a 45, and r in the question is given as negative 2 by 3. Sum to infinity is equals to A divided by 1 minus r. So sum to infinity then shall be equal to 45 divided by 1 negative 2 by 3, or I can say it's 45 divided by a 5 by 3, or sum to infinity then shall be equal to 45 into 3 by 5, and simplifying the work, I should say it's equal to a 27. So sum to infinity then becomes a 27 here. This question here is from May-June 2011, variant 2, paper 1, and it's question number 10th here. So the question says a circle is divided into 6 sectors in such a way that the angles of the sectors are in arithmetic progression. Angles are in arithmetic progression, and it's getting divided into 6 sectors, meaning 6 sectors, that means we have the n value, which is a 6, and obviously they are in arithmetic, the angles are in arithmetic progression. Let's start the solution here. So if we start the solution, then what I see here is that the data is about the angle of the sectors which are in arithmetic progression, and also they are saying it's the angle of the largest sector, which is 4 times the angle of the smallest sector, meaning theta L, the angle of the largest sector, shall be equal to the angle 4 times the angle of the smallest sector here. And then the radius equals a 5 centimeters. The radius, which equals a 5 centimeters, find the perimeter of the smallest sector. So if we are supposed to find the perimeter of the smallest sector, then what I know here is that the sector of a circle is given by the diagram, which can be from the center up till the circumference. We have the radius, and this is the arc length that we shall be having. And for the perimeter, then we should say that the perimeter of the smallest sector then is going to be r plus the arc length. The arc length here is given as r theta. The arc length of this sector is given as r theta, where r is the radius and theta is the angle subtended by the two radii, in between the two radii, to give us the sector here. So if s equals r theta, then I can rewrite the perimeter as 2r plus r theta here. We know the radius. The radius is given as a 5, but we do not know the angle here. So the only thing that we need to find is the angle to get the perimeter of the sector. Another thing that we should be having in our data is the n value, where they are saying that n equals 6, because they have divided this circle into 6 sectors. Find the perimeter of the smallest sector. Let's use the term formula for arithmetic progression, where we say that L, which is the largest sector here and the last sector for us, shall be equal to A plus n minus 1 times D. L here is in terms of theta, so we are talking about the largest angle. A is the smallest, and then plus 6 minus 1 times D here. Here theta L, we already know that theta L here equals a 4 theta for the smallest. Therefore, I am substituting this theta L with 4 theta smallest, which shall be equal to theta smallest and then plus 5d. Or I can say it's 4 theta minus theta, giving me a 3 theta smallest, which shall be equal to a 5d. Or I can say that the common difference here shall be a 3 by 5 of the smallest theta value. So I have the entire circle, then we know that the sum of all the sectors, let's say we shall be having 6 sectors here. Let's say these are the 6 sectors that we have. Then we know that the sum of all the sector angles shall be equal to 360 degrees. So the sum of all the 6 sectors here shall be equal to 360 degrees. Applying the sum formula, it's Sn, which equals n by 2 times 2a plus n minus 1 times d, or I can say it's 360 degrees. N is equal to a 6 divided by 2. A here is going to be the theta of the smallest sector, plus 6 minus 1, giving me a 5 times d, and for d I will be substituting 3 by 5 theta of the smallest sector here. So the 5 gets simplified. I will here be left with 6 and 2 also get simplified, and 360 divided by 3, that will give me 120 degrees, which shall be equal to 2 theta of the smallest sector plus 3 theta of the smallest sector, and here I can say it's equals 5 theta of the smallest sector here. Or I can say that the theta for the smallest sector here is 120 divided by 5, or we should say that this theta smallest shall be equal to a 24 degrees. So this is the smallest angle for the 6 sectors that we have in our question. Theta equals 24 degrees here. After getting this theta as 24 degrees, just remember then that when we are finding out the perimeter with the formula S equals r theta, then we should be having our theta values in terms of radians. So that means if our theta is 24 degrees, I need to convert this 24 degrees to the radian value. And to convert this degrees to the radian value, I should know that it's 180 degrees, which equals to a pi radian, or I can say it's a 24 degrees then, which shall be equal to an x radian. So x radian here shall be equal to 24 divided by 180 times pi. So this theta value in terms of radian shall be equal to a 24 pi divided by 180. So this angle value here is going to be a 0.41888 radian. So this is the angle value for the smallest sector, which is equals to 0.41888 radians. Substituting this in the perimeter formula, which is equal to 10 plus 5 theta. So for 10 plus 5 theta, I should say that my perimeter here was 10 plus 5 theta smallest. So it should be equal to 10 plus 5 times 0.4188, or I can say that this perimeter is going to be 12.1 centimeters. So this is the only part that we should be knowing, that when we have calculated our angles in terms of degrees, then to find out the perimeter, please do not forget to convert the degrees into the radian mode. This is the conversion for degrees to radian. So the second part of the question says the first, second and third terms. These are the first, second and third terms of a geometric progression. And for this geometric progression, this is the first term, second term, and this is the third term here. Given that all the terms of the GP are positive, you need to calculate the value of the constant k. So to find the value of the constant k, the three terms, the first three consecutive terms, they are given to us. So with respect to the first three consecutive terms, I should say that my first term is 2k plus 3, my second term is k plus 6, and my third term is a k. We know the common ratio. This is our T1, this is our T2, and here we have our T3. We know the common ratio, which can be given as T2 over T1, or we can say it's T3 over T2. So substituting the third term, which is a k, the second term, which is a k plus 6, divided by the first term, which is a 2k plus 3, I should say that this equals the third term, which is a k, divided by the second term, which is a k plus 6 here. Solving it further, I can say that it's k plus 6 times k plus 6, which shall be equal to k times 2k plus 3. तो झटको पहले फिर बिछाओ, पैर उसका ऊपर करो, ऊपर करके झटको. This can be written as k plus 6 the whole square, which equals 2k square plus 3k. So applying the identity for a plus b the whole square, a plus b the whole square, I know that this is equals to a square plus 2ab plus b square. Therefore here this becomes k square plus 2 times k times 6, that will give me a 12k, and then it's a plus 36, and this shall be then equal to 2k square plus 3k. Or solving it further, I can say that this is a 2k square minus k square, that will give me a k square plus 3k minus 12k, that is a 9k, and then here I should be having a negative 36, and this shall be equal to a 0. So factorizing this equation, k square minus 9k minus 36, the factors here shall be k square minus 12k plus 3k minus 36, which is equals to 0, or k common, I'll be left with a k minus 12 plus 3, and then it's going to be a k minus 12, which shall be equal to 0. Solving it further, it's k minus 12 and k plus 3, which shall be equal to 0. So k here can be equal to 12 and also k can be equal to -3. So k equals -3, that's not possible, as the question itself has very clearly said that the geometric progression here needs to be a negative. So I should be considering the value of k, which is equals to 12, as my answer. Part B says find sum to infinity of the progression. So to find the sum to infinity, we know that the ratio, the common ratio, is t2 by t1 or t3 by t2. So I need to, now, after having the value of k, I need to have the exact value of the common ratio as well as the first term. The first term is 2k plus 3. So here, solving for part 2, the first term here is 2k plus 3, and we know that the common ratio here was equal to k over k plus 6. Let's take a simple value, which is k over k plus 6. Substituting our k as 12, I can say that a is equals to 2 times 12 plus 3, or a then shall be equal to a 2 times 12, which is a 24. 24 plus 3, that will give me a 27, and r here then shall be equal to 12 divided by 12 plus 6, or we can say it's 12 divided by 18, or further I can say that this shall be equal to 2 by 3. So if the question is asking for the sum to infinity of the progression, the question is asking for sum to infinity. For sum to infinity, I should be having my a as well as my r. Sum to infinity here is equals to a divided by 1 minus r. Substituting these values, it's going to be 27 divided by 1 minus 2 by 3, or I can say that sum to infinity here is going to be a 27 divided by a 1 by 3, or I can say it's 27 times a 3, which shall be equal to a 81. So this is going to be the answer for sum to infinity here.